Yeah.
Hi, Shiva.
Hi, sir.
So you're doing a cloud formation demo today? First demo, I think, right? For cloud formation.
Yeah, this is the first demo on cloud formation.
So are you giving introduction about the cloud formation also in this demo?
Yeah, yes, sir. Yes.
Yeah, go ahead. Just go ahead.
Okay. So this is a demo about cloud formation with Mariadb-RDS database with a manual process and cloud formation template also. So this is an introduction about to cloud formation. So basically, the cloud formation template is a text file format in JSON or YAML language. So you can choose either JSON or YAML language. So that describes your whole AWS infrastructure that you want to uh, create the infrastructure by using this JSON or YAML template. So basically the AWS resources can be created or updated by using a stack. So the stack is nothing but it is a group of resources which is present in the JSON or YAML file. So it is a one text file format. So inside that there are some group of resources. So that is nothing but a stack. So you can reuse these templates to replicate your infrastructure in multiple environments whenever you need to execute this particular infrastructure. Then you can replicate this particular infrastructure in multiple environments. You can easily use these templates. So to make templates reusable, so use the parameter section and the mappings and the conditions also. So in that you can customize your stack whenever you need to create them in particular multiple environments, so that you can customize your parameters and mappings and conditions. Then you can reuse it. So all the resources which you need to require in a particular application, so that can be deployed easily by using this JSON or YAML templates. So with the help of cloud formation. So basically this is the structure of JSON template. So the first thing here is the template format version. So it describes represents this version with a template version. So the next thing is the description, so which describes this template JSON string. So this is the JSON format, and the metadata, it will describe the more about your information about this template. And the parameters section, it is a set of parameters which you need to require to give the parameters inside under the parameters section. And the rules also, it is one of the part of the inside this JSON template. So if you want to mention the some rules, depending on the rules it will execute this template. And also the conditions also, if you want to give the condition, particular condition, then execute the under the you need to give under the conditions here. And also the transform section also is available. So and the resources, so the main part is we need to give the resources part. Under the resources part we are creating the infrastructure by using this JSON template. So the last one is output section. So basically this is for used to in order to mention some output of the while creating this template stack, so that it will execute it will visible at the end of this template. So this is the basic structure of JSON template. And similarly the YAML template also is looks like similar, like description template version, metadata, parameters, rules, mappings, conditions, transform, resources, outputs. So all the sections are similar either in JSON or YAML template, but the only difference is, so here the curly braces is you need to mention inside under the section also. So here there is no need, only the string is available. So okay, let's move on. So this is my agenda today. So in this demo I am going to demonstrate the following uh, setup. So first one is the manual setup by using this RDS Mariadb RDS. And the second one is I'm going to execute with ML code uses with cloud formation. Once we created, we can update also for the change request in order to implement some more resources in the stack itself. And the third one is I'm going with the JSON code usage with CloudFormation template, and we can also update the stack in order to change the request according to our requirement. So this is my agenda today. So let's get started with the first step, manual setup. So this is our architectural diagram so here the VPC is, so this is the VPC region so this is my public subnet. Under this one EC2 web server is available. So this is my private subnet 1 and private subnet 2. So we can connect from the RDS through this web server. Then this is the virtual router in order to route the traffic from this web server to the outside. So this is the internet gateway in order to route the traffic from this web server to the customers through this internet gateway. So in order to do this demo, this is the prerequisite. So the AWS account setup and this IAM user having below permissions, VPC full access, EC2 full access, and administrator access. So I'm going to do the task according to this. The first step is the custom VPC setup. So first we need to create the one VPC setup, and inside the VPC we need to create the subnets, public subnet and 2 private subnets, and we need to create internet gateway in order to route the traffic from this subnet to the outside. Then we need to route the table settings, public and private route table settings, and we need to create the security groups also for the EC2 and the RDS security groups, and we need to launch one EC2 instance in public subnet in order to connect with RDS. Then we need to launch a Mariadb instance in private subnet, and we need to attach this NAT gateway in order to route the traffic to the private subnets. Then finally we need to install the RDS and configure this DB on private instance. So the first step is creating the custom VPC. So this is task 1, creation of the VPC setup. So just log into the AWS console, and this is the VPC settings. So this is the name of the VPC. So this is the IPv4 CIDR block range 10.10.0.0/16. So we can create. So go to AWS region. So this is my AWS console. So let's log in with VPC. So go to your VPCs. So click on create VPC. So you need to mention the name VPC. Okay. Then we need to give the IPv4 CIDR range. Let me give 10.0.0.0/16. The VPC CIDR block range. Then just go on create VPC. So we created one VPC, custom VPC demo. So this is the task 1. So in the task 2, we need to create the subnets. This is for public subnet creation. So this is the subnet settings, public subnet, and the availability zone is US East 1A. This is the IPv4 CIDR block range. So let me create the subnets also. So create subnet. So you need to choose your VPC, custom VPC. So we have created this VPC demo. Select on this. Then you need to mention the name of this subnet. Public. So select your availability zone, whichever you need to want. Select this US East 1A. And you need to mention this CIDR block range 10.0.1.0/24. It's my divided network. So click on create subnet. So this is my public subnet, and also you need to create the private subnets also, private subnet 1 and private subnet 2 also. So create subnets, choose your custom VPC. So just give the name private one, choose the availability zone US East 1B, then give the CIDR block range 10.0.2.0. okay, select this. So we need to create another private subnet also, so add new subnet. So give the subnet name private 02. This is the second private subnet. So let me choose this US East 1C region availability zone. So let me give the IP range 10.0.3.0/24. So we created one public subnet and two private subnets. So click on create. So we need at least two private subnets in order to create the RDS. So we have created one public subnet and two private subnets. So in the task 3, we need to create internet gateway in order to route the traffic. So let me create internet gateway. So click on internet gateway. So create internet gateway. Gateway 1. Then click on create. So you need to attach to the VPC. So select your VPC, so attach. So internet gateway is successfully attached to our VPC. So, and also you need to create the route table settings in order to connect with subnets. So let me create the public route table and also private route table also. So first let me create a public route table. So click on create. So just give the name public route table. Select your VPC. So create. So go to route tables. So this is public route table. So similarly, private route table also. So create route table for the private subnets. Private. Select your VPC. Create route table. So click on route tables. So we created public route table and private route table in order to connect subnets. So let me connect that public route table. So click on that. So go to actions, edit subnets. So choose your public subnet, save association. Similarly, go to this private route table. So click on actions, go to this edit subnet association, choose your private subnets, then click on save. And also we need to connect this internet gateway to the public. So let me connect this, go to actions, click on edit routes, so add route table. So the destination is 0.0.0.0/0 and the target is internet gateway traffic. So select this, so click on save changes. So public route tables. So I created the route tables also, and we have associated with the public as well as the private subnets to the public and private route tables. So let me create the security group also for the EC2 as well as the RDS. So before going to this, let me create the NAT gateway in order to connect with this private route table. So go to this NAT gateway. So create NAT gateway. So choose your subnet. This public subnet. So allocate IP. Then create NAT gateway. So NAT gateways, it will take some time. So while meanwhile, let me create the security groups for the EC2 and the web server and the RDS also. So go to the security groups. So click on create security group. So this is for the EC2 web server security group. Allow 22. So choose your VPC, custom VPC. Then you need to add the rule, inbound rule. So this is for SSH. So just give this anywhere. Then HTTP. So select anywhere. The outbound is all traffic. So click on create security group for the EC2 web server security group. So let me mention this tag name. Similarly, the RDS security group also. So click on create security group for the RDS. So just to give this description, port number, yes. Just so select your VPC, then add this inbound route. So this is for only this MySQL RDS. So select your custom VPC .0.0/16. So this is my outbound route. So create security group for the RDS. So let me give the tag name also. Okay. So we created the security groups also. So let me launch EC2 instance in public subnet. So before going to this, let me create the DBs. Let me create the RDS. So while in the meanwhile it will create it, then we can create the EC2. So let me take this duplicate tab. So click on RDS. So in order to create RDS, so first you need to create the DB subnet group for the RDS. So this is the, you need to choose this create a DB subnet group. On the create DB subnet group, you need to set the values, the name of the subnet group, and the description. Then you need to select your custom VPC. Then you need to add the private subnet availability tunes. Okay, so this will create the subnet group for the RDS. So go to the subnet groups. So let me delete this. So create DB subnet group. Then okay, this is optional. Then choose your VPC, custom VPC. Then you need to add the availability zones, private availability zone 1B and 1C. So it should need, at least you need 2 private subnets. So let me create. So it means you need to description. Okay. Yes. So let me create. So DB subnet group is created. Then you need to launch the DB instance. So you need to launch the DB instance where you need to and choose the AWS region where you want to create the DB instance. So this is the description. Make sure the standard create option is chosen. The standard, okay, let me go to, I will show you. So click on create database. Okay, so this is the creation of database page. So first we need to select this standard create option. Then in the template section, choose the dev1 test. So here options are there. So I'll select this Mariadb database, and in the choose the sample template to meet your use case. So for this demo, I'll go with the dev test option. Then in the settings sections, you need to set the rules according to your requirement. So the DB instance identifier name is my DB instance. This is the username DB user, and you need to give the password, create the password, and you need to mention the master password, and you need to confirm the password also. So let me give this. So let me give this name as this. Okay, let me leave it. This is the admin. So let me create the master password. If you want, you can change this username also. So let me give again password confirmation. So under the instance configuration, select your burstable class. Let me select this. So 2-3 micro for this demo. Under that storage, you need to select this general purpose SSD, and the storage is 20 is enough. Then under the storage auto scaling, so we are not using any auto scaling feature. Let me disable this. So under the availability and durability, so okay, leave it as it is. So under the connectivity, so choose your VPC demo, custom VPC, and this is our subnet group which we have created earlier. So the public access is no. So this is since DS, so we should not able to give the yes. So under this VPC security group, select your DS security group. So this is the database port. It should be WSO6 enabled. Then leave it all the options by default. So click on create database. So just I followed the steps here, the port number and the VPC, the subnet group. So it will take a time. So meanwhile, we will create this launch one EC2 instance in public subnet. So let me go to this EC2. So go to these instances. So launch instance. So have the steps here. So choose your VPC, custom VPC, and the public subnet. Then enable this public IP, and then choose your web security group, web server. Then give your key pair, and just launch the instance. So just give the name. Then choose your OS. I'll choose Ubuntu, the 20 version. So this is T2 micro. So select your key pair. So under the network settings, you need to make changes. Select your custom VPC. Then this is for public subnet. So we need to enable this auto assign public IP. So the firewall security group which we have created already. So let me select that web security group for this EC2. So okay, let me launch instance. So go to instances. So meanwhile, so our RDS database is creating. It will take some time. So once our server is ready, then we can connect. Okay, our server is running state, so we can connect here. So click on connect. So the connection methods are types. So let me go to this browser-based connection. So click on connect. So I have connected here to the EC2 instance. Okay, the user data is okay. Let me give the manual. So let me update this server. The apt update. So let me clear the screen. So let me launch one Nginx web page. apt get Nginx. Click on web. Let me verify this into this public IP. Enter. So Nginx is installed in our EC2 server. So let me go to this RDS. Meanwhile, let me go through the steps. So we have created EC2 in the public subnet, and we have launched on Nginx webpage on the EC2. Then we have created also the NAT gateway and attached already. Then we are creating this DB instance, so it will take time. So once the DB server is ready, then we can install this Mariadb on the EC2. Then we can connect with this command mysql-h, the endpoint of your RDS. Then this is the port number, and this is your master user while creating this database in the RDS. So the next thing is, so this is for cloud formation. Okay, so up to here, this is the manual process. So later we can go with the cloud formation template. Okay, meanwhile, I will explain this the JSON template. So this is my cloud formation template. So as we have discussed already, so the template will looks like the first one is the template format version and the description. So this is the description: AWS Cloud Formation template for creation of bastion host instance with security connectivity. And the next one is we need to mention the parameters whatever we require. Then it will mention under this parameters section. So this is the first one, environment name. So this is the description about this environment name, and the type is a string, and the another parameter is key name for the EC2. So this is the description: name of an existing EC2 key pair which is available in our AWS in order to enable this SSH access to the particular instance. This is the type: AWS EC2 key pair key name. So it will list all the key pairs which are existing in our AWS console. This is another VPC cited block range parameter. So this is the description. We mentioned the CADL block range for our VPC. So this is the, it will type the string. So this is the default option. So if you don't have don't given this default option, then it will take the default option from this few. And this is the public subnet parameter. So this is the description, and you need to mention this availability zone, and the type is a string. So this is the default value I am mentioning here, 10.0.1.0/24, and this is the private subnet one. So this is the description. So every parameter also the description and the type and the default values I have mentioned. So this is the private subnet one, 10.0.10.0/24, and this is for public private subnet to CIDR. the description, and again the type and the default values. So when it comes to the DB database parameters, so this is the parameters I have mentioned over here. So this is the DB class, the type is a string. So this is the description or this instance class. So here I am allowing values are T2 micro and T2 small. So this is the description about allowed values, but I have taken this T2 micro from the default. So if you mention here T2 small, you can mention here. Then the master username in order to connect with the database, the type is a string. So this is the description, master username for the DB instance. So the maximum length is 10, and I have mentioned here the default DB admin is the master username. So the pattern should allow the pattern in between these letters and numbers. And finally, I have mentioned this no echo is true. So it means you don't have to mention shown here. You can just it will doesn't appear. So this is the DB parameters, master user password, and multi availability zone is this is for enable multi availability zone. So the allowed values are true or false, but I have given this for this demo false, and the allocated storage for the RDS. So the set type is number, description, database storage size in GB. So this is the minimum value, this is the maximum value. I have taken the default is 8 GB. Okay. So my RDS database is now available. So let me go to this. Okay. So let me go to my instance EC2. So let me upgrade once again the EC2 server. Okay, so clear the screen. So next I'm going to install the Mariadb client on my EC2. apt Mariadb client. Enter. Click on well. So at last need to connect to the database. So let me execute this command. So copy this command and let me paste it over here. Let me give this master username while creating our DB. So this is admin. I have given admin name. Endpoint you need to mention. So this is our RDS endpoint. So let me take this. So let me enter. So we have already given the password. Let me execute that password. So we have connected this Mariadb inside this from the EC2 server. So let me exclude this how many databases are available inside this Mariadb show. We execute this command, we can able to know the how many databases are available. This is my SQL database is available. So if you want to, you can create more databases and you can execute this data. So that is the manual process in order to connect with RDS from the EC2. So the next thing is we need to do with the CloudFormation template. The both formats, JSON and ML file. So we have discussed these parameters, and the database parameters also. Okay, this is the code for the ML and the JSON. So let me discuss this code also. So this is for the resources part. This is the ML code and this is the JSON code. The first one is creation of VPC resource. So this is the VPC logical ID, and the type of the resource is AWS EC2 VPC. Then it is the properties. It has the properties. Under the properties, this is the shader block range, and we are calling this reference function from this parameter section, and we can just assign this VPC shader block range inside here. Then the properties are enable DNS support is true, and enable DNS hostname is also true. And for the tags, you need to mention key is name, key value pair. Then the value is we're calling this reference function environment name. So we are created at first. See, this is the environment under the parameters. So we are calling this function under the tags inside the VPC. This is the ML code, and similarly this is the JSON code. Similarly, the resources part, we are mentioning this logical ID VPC and the type and the parameters. So under the parameters, this is the shader block range and the enable DNS hostname true. Then we have mentioned the tags. So the main difference is we have just mentioned the curly braces, and under the inside the curly braces we have mentioned the parameters. So this is for creation of VPC in both the ML and the JSON code. So this is the creation of internet gateway. So this is the logical ID internet gateway, and this is the type of the resource AWS EC2 internet gateway. These are the properties for this. The tags I have mentioned this, calling the function environment name for this internet gateway. So I have attaching this internet gateway to VPC. So this is the logical ID internet gateway attachment. This is the type of resource AWS EC2 : VPC gateway attachment, and this is the property for this. So internet gateway ID. So we are referring this internet gateway from the parameter section by this reference function, and also the VPC ID in order to connect to the VPC, this internet gateway. So we are calling this VPC function from the parameter section. Similarly, the code is looks like the same. The logical ID internet gateway and the type and the properties, and inside this tags also. And in order to connect with the internet gateway attachment, this is the type and this is the properties. So this is for the creation of public subnet 1. This is the logical ID and the type of the resources AWS EC2 : subnet, and the properties. So every resource has the logical ID and the type and the properties it has. So this is the VPC ID in order to mention inside the VPC for the public subnet 1. This is the availability zone. So inside the availability zone, I have taken this function select. So you can select the availability zone. We have seen already in the manual. Then also this is the get availability zone. So we are referring this AWS region from the parameter section. So whatever the specified region is available, so it will select on the particular region also, particular availability zone. So this is the shader block range. we have mentioned already inside the parameter section by calling this reference function here. And the map public IP launch is true. Since this is the public subnet, we have just to mention here true, and this is the tags for this public subnet. Similarly, it looks like this code is same for the JSON also. Then this is for the private subnet one. This is the logical ID, and this is the type AWS : EC2 : subnet, and this is the properties. So we have mentioned the calling the reference VPC, and this is the availability zone by using this function select and get availability zone. So it will select the particular in the region the availability zone. Then this is the CIDR block. We are calling this reference function, this private subnet one CIDR from the parameter section, which we have discussed earlier. This is the map public IP launch false because this is the private subnet, so we don't want to give this to the public. So this is the tags. Similarly, the code is same for the ML and JSON. So this is for private subnet 2. This is the type of the resource, logical ID AWS : EC2 : subnet. So these are the properties, VPC and the availability zone for the subnet, and this is the CIDR block range, and the public on launch is false. These are the tags. This is for the public route table creation of the logical ID, and this is the type AWS : EC2 : route table, and we need to mention the properties for this public route table inside the VPC. So I'm calling this reference function VPC, and I have just given the tags with the environment name public route. This is for the public route. So this is the public route table, and this is for the public route in order to connect with the subnets. So this is the logical ID, this is the type of this resource, and it depends on the internet gateway. Yes, so we are connecting from the internet gateway, edit routes, right? So these are the properties, route table ID. We are calling this public route table from the parameter section, and this is the CIDR block, which will allow from the 0.0.0.0/0, and the destination is internet gateway. This is the internet gateway ID. We are calling a reference function from the parameter section. So similarly, this is also the same code for the MLM JSON. So this is for the public subnet 1 route table association. This is the logical ID, and this is the type of the resource AWS : EC2 : subnet 1 association, and these are the properties in order to connect with the route table, and we are calling this function reference by using this reference function from the parameter section, and this is the subnet ID, public subnet ID, which will connect to the subnet. And this is the creation of a private route table in order to connect with private subnets, and this is the logical ID private route table 1, and this is the type of the resource AWS : EC2 : route table, and these are the properties. This is for the private subnet 1 route table association, and this is the type AWS : EC2 subnet route association, and this is the properties which we need to connect with the private route table and private subnet 1. We are just calling this by using this reference function from the parameter section. And similarly, this is for the creation of private route table 2 inside the VPC. So yeah, this is for the private subnet 2 route table association. So this is the type of the resource, and these are the properties which we need to connect with private route table to the private subnet 2. So this is for the RDS security group. So this is the logical ID RDS security group, and the type is AWS : EC2 : security group, and these are the properties for this secure RDS. The group name is RDS security group, and this is the VPC which we need to select the VPC, right? So this is for calling from the parameter section, and this is the description. Enable this port number. This is the description So this is the security group ingress means it is the inbound rule. So the protocol type is TCP from the port database port 33062 port 3306, and we are calling this security group from the parameter section, web server security group, and we have given the tags also RDS security group. And let me create this web server EC2 also security group. So this is the logical ID web server security group, and this is the type of the resource, and these are the parameters, description, and the VPC. Under the VPC and the security group also, here we are mentioning this SSH 22 and also the ID for this EC2 web server security group. So this is for the creation of EC2 web server. This is the logical ID. This is the type AWS : EC2 : instance, and so this is the properties for this EC2. The type is T2 micro, and this is the AMI ID for this EC2. This is the key names tags, and this is the key name in order to connect with the key name, and this is the network interface. We need to enable this public IP address true, and this is the device index is 0 string, and you need to mention this group set security group for this is EC2 in order to connect with. So this is calling from the parameter section, and this is the public subnet one we have connected. And this is the bootstrap script for the EC2. This is the user data. This is the function base 64. So it represents the all in the input for this user data script. This is the function join. So it will connect all these different multiple lines into the single line with the by using the separated by /n line. So these are the script, user data script, sudo m update -y to update the server. This is for installation of HTTPD, and this is the installation of MySQL server on the EC2. So this is the user data script for the EC2, and this is the creation of this subnet group, RDS subnet group, and this is the type RDS subnet group, and this is the property subnets to launch DB instance, and this is the group name RDS DB private subnets. We need to mention this two subnets to create the DB subnet group. So we are calling the functions from the parameter section, and this is the creation of MySQL database. So this is the logical ID database instance, and this is the type of the resource, and depends on the subnet group. So first it should create the subnet group, then we can launch this DB instance. So under this, the properties are mentioned over here. So this is the DB instance class. We can refer from this parameters section, and this is the Mariadb. Then multi-availability zone we can call from this parameter section. So publicly accessible is false, and the storage and master username, all the parameters are mentioned. All the variables are mentioned under the parameter section. So let me get the stack. So click on cloud formation. So go to cloud formation. So click on create stack. So here this is the create stack page. So this is the template, prepare template. We have three options. Template is ready, use a sample template, and create a template is design. Okay, I'll go this template is ready. So the template source is two options. Either you can go with the Amazon S3 URL. So before this, you can store your file into this S3 bucket. You can just go with the upload a template file. So choose file. So I have in my local. cloud formation. So let me open this Notepad++. So this is my YAML template. The structure is first, this is the template version. First we will create, and I can explain that code. So if you want, you can change here. View in designer, you can verify here. So this is your template. You can choose either JSON or YAML. Okay, let me click on here. So this is our architecture. So let me just so if you can just click on here, so whether the template is valid or not. So the template is valid, so it shows that. So this is for the creation of stack. So click on this. So it will redirect to the creation of stack page. So let me upload our template file, YAML file. So click on next. So enter the stack name. Cloud formation stack demo. So these are the parameters I have mentioned over in my file. So let me discuss that. So these are the parameters, environment name, and this is the key name. This is the VPC, and this is the public subnet one, and this is the private subnet one, and this is the private subnet 2 also. So this is for the DB class RDS. So inside this we have the allowed values and the master username, master password, and this is the multi-availability zone. This is the storage. So under the resources, this is the VPC. We have discussed this one, right? VPC and the internet gateway, and attached to the internet gateway to the VPC, and the public subnet one creation. Similarly, private subnet one and private subnet 2, the type and the properties. So we have discussed already. The public route table that connect with subnets, public subnet, and the private public subnet one route table association, and this is for the private route table. So private subnet route table association, the private route table 2, and last we can create the security group for the database and also the EC2 web server security group. So this is for the launching of web server with the user data script, and this is the subnet group, RDS subnet group, and this is the database instance with all the values, public engine, multi-availability zone, allocated storage, username, password, everything. So let me go to these parameters. So by default, I have mentioned some values inside the parameter section. So here the default DB class D2 micro I have mentioned here, and the master username I don't have mentioned here. So let me just go to this console. So whatever I have mentioned the default value, so it will take from the input from the default value. So if you want, you can select the T2 small also. So let me, okay, admin. If you want to change, you can change here. So let me select this key pair, first key. I will just username. So you need to enter environment name, right? Virginia. Okay. So master username. DB. Then okay. So the multi-availability zone I have given false, right? So if you see here, multi-availability zone, so it take from this default input value false, and the allocated storage is default value is 8, so it taken from the input from the default value. So this is the storage 8. So this is the private subnet 1 sided block range, and this is the subnet 2. This is the subnet public subnet 1, and this is the VPC. So click on next. So this is the tags. If you want, you can mention the tags, and this is the IAM role. If you want, you can. So I don't have any roles here to attach. So this is the tag stack value options. So all the options, I'll just go with the default. So click on next. So this is your stack review. So once you can verify all the information is correct. So this is the storage. This is the DB class and the environment name and the key and the master. So all the values we have mentioned over here. Then click on submit. So it will take some time to create the resources. Okay, meanwhile, let me delete this database. So this is I have created manually. Let me delete this. Okay, if you see here, what are the logical IDs we have mentioned? Let me verify. A VPC, web server security group, RDS security group, and the DB subnet group. This is the public subnet 1, public subnet 2, private subnet 1, private subnet 2, and the route table for the public and private and the internet gateway, and this is our database. So almost all the resources are created. So accept database. So it might take a few minutes. See here the cloud formation stack demo. So okay, this database is deleting, right? So this is creating here. T2 micro. We have mentioned that. So just we have entered our stack details, and we create the right. We refresh. So the DB is creating. So if you go to this outputs, so we don't have mentioned any outputs. And if we go to the parameters, so these are the parameters. So we have mentioned in the template. So this is our template, the version and the parameters, whatever the parameters we have created, and we can assign with under the resources part, VPC and the internet gateway attaching to the VPC. So all the things. So this is the template. We go to change sets. We don't have any change sets. We go to the events. So this is the logical IDs. So if we refresh, we go to the EC2. Okay, this server is already created, so let me delete. So we have created this manual there, so let me delete that. So this is initializing our web server through the cloud formation template. Stack information. So this is our stack ID, and the status is in progress state. This is the time stamp. So these are the stack options. Create change set for current stack. If you want to change this current stack resource, then you can change by using this option. You can import also the resources into your current stack, and you can cancel the update stack, and we can continue with this update rollback. All the options are available here. So the DB is taking time. So the status. So our stack CF stack demo is completed. So let me, okay. So this is our server, web server is ready. So let me connect this through this SSH connection. Go to, this is the EC2 user. So this is the Amazon.
So you can connect to backend DB server also and try to insert one record and show that also, the backend DB server. You got it? What I'm saying?
So first I have to connect with this server.
Yeah, front end public EC2. Then later you need to download that file, right? Key file from
Yeah.
S3 and connect to the private server, DB server.
Yeah, first I'll connect to this EC2 server.
Yes, yes, yes.
So let me. Okay. Okay, before. We go to the RDS. Okay, so the RDS is now available state. So this is our Amazon Linux server. So we give this command apt update. Sorry, this is Amazon server. So okay, M is the dependence. So there are no packages, right? So we have already given this command under the bootstrap script. So okay, let me give this my SQL. Okay, SQL is not installed. So let me connect this. So this is the command. Username. So this is the cloud formation stack demo. So let me go inside. So this is the endpoint. So copy and paste it over here. So click on enter. You need to enter the password. So we have connected the DB successfully. So
Yeah, Mariadb, right? Now you can insert any, create any table there. There is no table, right, as such. No.
Uh,
Semicolon.
so actually I have, oh, okay, I'm not inside this DB, right? Okay, let me exclude it. Create address. My DB is created. Database. So what you said, the table, right? Mm,
You create the database, and in that database, you need to create table. New database.
so first I will
So
just. Mm,
if you don't have commands readily available, that is fine, leave it. You have connected to the database, you verified it, that is enough, because connection is important and showing the existing databases are important. Okay, now let us not spend time on these things. Now, what is your next topic? Next one, what you are going to do? Task.
just I have here I have updated this ML file. So let me
Mhm. You
update
want to
this stack.
show with JSON also in a separate stack, or how? You have to
Yes, yes.
remove this existing stack, right?
Yeah, now I will update this stack.
Oh, okay. Update option you want to show. Okay, stack update.
Yes. So go to this update option. So choose the replace current template.
But what you want to do in update?
So in the
What
update,
component you want to add in AWS?
one more EC2 server,
In private or public?
public.
Okay. You have the code readily available, that code snippet. First you show that before updating this.
Okay.
You have the updated version of the code, this template.
Yes, yes.
You explain about that.
So the same template I have taken here, but at the end of these resources, I have added one more EC2. So this is my logical ID, my instance, and this is the type of my resource, AWS EC2 instance, and this is the properties. I have just given this T2 micro, and I have taken one image ID, and I have just given this tags name for this server. So remaining the code is everything is same, but I have just added one more EC2 server in the stack itself. So if you just go here, if I take this upload template, updated file, So this is my updated ML file. So click on next. Okay, so all the parameters are already taken this from the previous stack. So let me. Okay. So click on next. So the take everything is default. So this is the existing values parameters. So in the changes set preview, so here you can see this one more resource will be added. Now it is in update in progress. If you go to this. So at present I have only one web server. So let me. So once I updated this stack, if you want, you can mention whatever the resources you need to update in the stack itself.
Okay.
See here, create in progress. One more main instance logical ID.
Cycle, if you have any questions, you please ask.
So the stack.
You are on mute, Cycle.
Yes, I am here.
You can ask questions if you have any questions.
Okay.
So let me verify the console. So one more EC2 is added here, Ubuntu server. So that it is initializing now. So that one can able to create more resources if you want inside the stack, then you can create.
Can you show me one more time your this latest version of the template?
Yeah.
Code.
This is my updated ML code. So at the last of the resources part, I have added this.
So simply you created one EC2, no web server involved in that.
Yes.
Right, okay. Yeah, go ahead.
Okay, so let me go with JSON also. Similarly, okay, let me delete this tag. So click on here, delete. So meanwhile, I'll just go with the JSON in my local log. This one. So this is the JSON template. So it also has the similar code, the template version and the description. So these are the parameters, the environment name, key name, and the VPC shaded block range, and for the public subnet 1 shaded block range, private subnet 1 and the private subnet 2. So this is the VPC and one public subnet and the two private subnet block ranges. And this is the DB class. So inside this, these are the property values, allowed values, and the master name, master user password for the DB. This is multi-availability zone and the storage. So up to this, these are the parameters. So you can call these parameters inside the resources part. So this is the creation of VPC, internet gateway, and you need to attach the internet gateway to the VPC. Just you can call this function, then it will attach to this particular VPC to the internet gateway. And this is the creation of public subnet one inside the VPC with the block range, and this is the private subnet one, and this is the private subnet 2 creation, and this is the public route table one. This is the public route in order to route it connect with the public subnet and the internet gateway. So public subnet 1 route table association. Then this is the private route table. So private subnet route table association, and this is the RDS security group, and this is for web server security group. This is the ports 22, and this is 80 for the web server security group, and this is the 3306 port number enabled for the RDS security group, and this is the creation of web server with the key name and tags and the subnet ID to the public subnet. So instead the public subnet, the web server is created, and this is the user script. And finally, this is the RDS subnet group, and this is the creation of a database with all the values which we have mentioned under the parameters section. I'll go to this once again. So we have all seen this manual setup. First of all, then we have seen this YAML code usage with CloudFormation, and we created stack with this CloudFormation YAML template, and we have updated the stack with some changes request, and we have added one more server in the stack itself. And now we are going to see this JSON code usage with CloudFormation, and we can change the stack with some change request. So it will take us. Okay, so the stack is deleted. So delete completed. Okay, so let me go to create stack. So let upload template. Choose your JSON file. So click on open. So click on next. Enter the stack name. If you see, we don't have any servers, right? So this is the parameter section. We have mentioned this storage is 8, DB class is T2 micro. Give the environment name. And select your key pair. Then this is the password. Username. So this is the public and private VPC block ranges. So click on next. So I'll just consider this all the by default options. Click on next. So this is the review of your CloudFormation template URL, and this is the description, and these are the parameters which we are considering. Then come down, click on submit. So it will take 5 minutes. So this is the resources. So almost resources are creating. So these are the values we have given all detail, and this is our template, JSON template. So these are the parameters. If we see public subnet, private subnet 2, and the DB class, and inside the DB class, these are the options: username, password, multi-availability zone, storage, and this is the resources part. VPC creation, internet gateway attachment, public subnet 1, then private subnet 1, private subnet 2, then public route table, public route table association, public subnet association, the private route table, private route association, then security group RDS, then web server security group for the EC2, then creation of EC2 web server with user data.
I have a question for Siva.
Yeah, Saika.
Yes, when you specify for the first manual creation, you specify the availability zone, like one of your web server was on 1D, US test 1D, one of them was one US 1AI.
Yes.
It should be specified on this the format template, or it's gonna be like using variables here.
Yeah, it has the variables. I will show here. So if you come to these parameters, okay, I'll just go here. So if you see here, yeah, see here. So when creating the subnets, availability zones, right? So here so this function will select this the availability zones are based on your region. Okay. So this is the AWS region. So whatever the region you are inside this, so it will select that particular availability zone. So we have here I'm not mentioning any particular. So it will select the random.
Randomly, but we can specify by if we need to choose.
Yes, yeah, you can specify here inside this string.
Thank you.
So let me. So the stack is creating still. So let us wait some more time. So this is only DB is taking time. Okay, see. So our stack is now ready. So okay. So our EC2 is also ready. So let me connect. So click on connect. I'll go to this browser based SSH connection. So click on connect. So if you mention this, update, it shows no packages are updated, means so already we have given this command in the script. So and also so click on So let me connect to the database. You get the username. Point RDS. So go to your RDS. So go to your DB. So take the endpoint. And you need to paste it here. So enter. Right. Let me enter password. Let me copy 1 second. Of your DB. On the endpoint, right? So this is your endpoint. What is happening? So it got stuck. Okay. Let me connect again. So I'll connect again to the EC2. So go to sorry, can't connect. So connect here. Now you can copy this command. Username. So click on enter the password. So have connected to the Mariadb. So the MySQL is available inside the database. Sir?
Yeah, so I've done right JSON demonstration also, right?
Yes. So
Okay, good. Go to the slide for that agenda. So basically what you have done, go to, yeah, you have done the manual setup demo, and you have done the ML code usage with CloudFormation to create two-tier kind of architecture setup with RDS in the private subnet and public subnet one EC2 with web server. Then you used the ML code, you have executed a stack and showed the stack also. Then later you removed the stack and sorry, you updated the code by adding another component, which is public EC2, and you tested that also. Then later you deleted the stack. Then you came back for JSON code to
yes.
execute the same setup. And in JSON code also you have created the stack. You showed that. After that, you updated the stack with another EC2 addition, right? You have done
Yes.
that for JSON also.
Still,
So these are the things, overall demo, you have done it. So it means from manual setup to ML code running in CloudFormation, then JSON code running, you have demonstrated it. It is a long demo. I think so far you have not done it, either in the AWS or Azure, like 2 hours demo, right?
yes, yes. This is the first one.
Right. Cycle, do you have any questions?
Yeah, I already asked my question to Stephen.
Yeah, yes. She has one question.
Okay. Here, Cycle, the
Yeah.
employers are looking to know the skills, multi-skill set using AWS. Like, do you know the manual setup? Do you know how to write the YAML code and update the stacks? Do you know JSON code, how to write it and how to update it? That's the reason I insisted him to prepare this demo, and I asked him to get ready for this demo. So he has done it. Now the same concept I follow for everybody, but in your case, you joined just a few weeks ago. It takes some more time to pick up and demonstrate it,
Yes.
right?
Yes.
Okay. So, right. So I'll stop recording.